The kissing bug emerges when the world sleeps. Hidden during daylight hours, it waits patiently within cracks of walls, beneath loose bark, or inside animal nests, perfectly adapted to a life lived in darkness. At night, driven by instinct and necessity, it begins its silent search for blood. Unlike insects that swarm or buzz, the kissing bug moves with unsettling precision, guided by heat, carbon dioxide, and subtle chemical cues released by breathing bodies. Scientifically classified within the subfamily Triatomini, kissing bugs are a group of blood-feeding insects native primarily to the Americas. Their evolutionary origins trace back millions of years, long before human settlements appeared. Initially feeding on wild mammals and birds, these insects evolved mouthparts specialized for piercing skin and drawing blood efficiently. This feeding strategy proved successful, anchoring the kissing bug firmly within its ecological niche. Physically, the kissing bug is built for stealth. Its flattened body allows it to slip into narrow crevices, avoiding detection. Long legs and segmented antennae enhance sensory awareness, while its elongated proboscis functions as a precision instrument capable of penetrating skin with minimal sensation. Many victims never feel the bite itself. Instead, the danger comes later, unnoticed, when the insect defecates near the wound, releasing microscopic parasites. The name, kissing bug, comes from its disturbing tendency to bite near the lips and eyes of sleeping humans. These areas offer thin skin and abundant blood vessels, making feeding faster and safer for the insect. Yet this behavior has unintended consequences. Within the insect's digestive system lives Trypanosoma cruzi, the parasite responsible for Chagas disease. When contaminated feces enter the bite wound or mucous membranes, infection begins. For the kissing bug, feeding is not aggression, it is survival. Blood provides essential nutrients required for growth, molting, and reproduction. Each feeding session supports the insect for weeks or even months. This efficiency reduces the need for frequent exposure, allowing the kissing bug to remain hidden for extended periods, further enhancing its survival. Habitats occupied by kissing bugs vary widely. In natural environments, they inhabit rodent burrows, bird nests, and hollow trees. However, human expansion has created new opportunities. Wholly sealed homes, thatched roofs, and cluttered sleeping areas mimic natural shelters, bringing humans into the insect's feeding network. This shift represents one of the most consequential intersections between wildlife and human health. Despite their sinister reputation, kissing bugs are not malicious creatures. They operate under the same evolutionary pressures as all organisms. Their success lies in adaptation, not intent. Yet the consequences of their feeding behavior ripple far beyond the individual insect, shaping disease patterns across continents. As night deepens, the kissing bug becomes a master of timing. It waits until breathing slows and movement ceases before approaching its host. Drawn by body heat and carbon dioxide, it navigates darkness with remarkable accuracy. Once feeding begins, saliva injected into the wound contains anesthetic compounds that prevent pain and anticoagulants that keep blood flowing. This chemical cocktail is a product of evolutionary fine-tuning, ensuring maximum efficiency with minimal disturbance. The real danger unfolds after feeding. Unlike mosquitoes, kissing bugs do not transmit parasites through saliva. Instead, Trypanosoma cruzi is released in feces deposited near the bite site. Scratching, rubbing, or even natural skin movement can introduce the parasite into the bloodstream. Infection often begins silently, with mild or non-existent symptoms, allowing the disease to progress unnoticed for years. Within ecosystems, kissing bugs play a complex role. They act as vectors, connecting parasites with a wide range of mammalian hosts. Wild animals such as armadillos, opossums, and rodents serve as natural reservoirs for T. cruzi, maintaining the parasite's life cycle independent of humans. In this sense, kissing bugs are not invaders but intermediaries, linking species through invisible biological pathways. Predators of kissing bugs include birds, reptiles, spiders, and small mammals. However, their nocturnal habits and cryptic behavior reduce predation risk. Some species possess chemical defenses that make them unpalatable, further discouraging attack. Survival, once again, favors discretion over confrontation. Reproduction is slow but deliberate. Females lay eggs in protected locations, ensuring offspring emerge close to food sources. Nymphs undergo multiple molts, each requiring a blood meal. This dependency reinforces the insect's intimate connection to vertebrate life and strengthens its role within disease ecology. Human efforts to control kissing bug populations highlight the challenges of managing wildlife-associated diseases. Insecticides, housing improvements, and public education have reduced transmission in some regions, yet eradication remains impossible. The insect's resilience, adaptability, and deep ecological integration ensure its continued presence. The kissing bug stands at an uncomfortable intersection between nature and humanity. It is neither villain nor anomaly, but a reminder that evolution does not account for morality. Its existence reveals how fragile human health can be when biological systems overlap. A single insect, acting on instinct alone, can alter lives through mechanisms invisible to the naked eye. Understanding the kissing bug requires moving beyond fear. Scientific research continues to uncover details about its behavior, genetics, and interaction with parasites, opening pathways for improved disease prevention. Protecting biodiversity while safeguarding public health demands balance, not eradication. In the broader story of life on Earth, the kissing bug illustrates a sobering truth: survival strategies that succeed in nature can carry unintended consequences in human society. Awareness, education, and respect for ecological complexity remain our most powerful tools. Small, silent, and often unseen, the kissing bug reminds us that the most significant forces in nature are not always the largest or loudest. Sometimes, they arrive quietly in the night and leave lasting marks behind.